Good morning, guys. Anjani Kumar here, dealing instrumentation subject for a final year electrical students. Right? In the last session, we have successfully discussed about thermocouple. Right? I just want to give a brief review on a thermocouple. So before going to thermistor concept. Alright? So what's a thermocouple? So thermocouple is nothing but a temperature transducer which will convert a temperature in terms of a voltage. Right? It's like an active transducer. It doesn't require any external electrical supply. And how it will work means the change in temperature. If you want to find out the temperature, unknown temperature, we can calculate it in terms of voltages in a metals. Right? So what is the working principle? So when two dissimilar metals which are joined together, it forms a two junctions, right? So one junction we can call it as a cold junction, another junction we can call it as a hot junction. So cold junction we can call it as a reference junction, that is at 0 degrees centigrade. Another hot junction, so whatever the unknown temperature that you are going to apply here. Right? So due to the change in temperature, the EMF will be generated. That EMF we can calibrate it in terms of a meter. So or a moving coil meter or a voltmeter. So how the voltage that you are getting, which is analogous to the temperature, change in temperature. How the change in temperature will produce a EMF that can be analyzed with the help of three effects. So those are Seebeck effect and Peltier effect and Thomson effect. Right? What is a Seebeck effect? Says that. So when two dissimilar metals which are joined together, it forms a two junction and there will be a voltage applied across each and every junction. So that is called E1 and E2. Alright, and what's the Peltier effect says that? So definitely in two dissimilar metals which are joined together, it forms a two junction and it will produce the EMF by changing difference in the temperature across the junction. Right? How the EMF generated? How the EMF generated means by changing the temperature, the EMF is generated. That what Peltier said. And what the Thomson effect says that definitely when two dissimilar metals which are joined together, it forms a two junction and the EMF generated, and that EMF can be moved, that EMF can be traveled throughout the length of the metal. So at any point you can find the voltages, you can find the EMF across the junctions. Right? So these are the principles that we are used in a thermocouple concept. I hope it's clear. And what is the equation? So equation A is equal to A into delta theta plus B into del theta whole square. So this is the relationship between the temperature and the EMF. So delta theta is nothing but change in temperature, and A, B are constants. So E is the EMF we are getting. Alright? So basically the B value is very less. So that means you are taking the metals at the type of a metals where the B value should be very, very less. So for this you have to eliminate the B value, you will get the equation A into delta theta. Right? So this is the relationship between the temperature and the change in voltage, temperature and the EMF generated. Right? So we will get the linear scale. Right? So what are the metals? Iron constant and copper. Right, chromel constant and chromel alumel, all those things that you will use for thermocouples and all these things. Right? What are the advantages? Means time lag should be very less. It will be used for 2600 degrees centigrade of temperature. We can measure these type of thermocouples, and it doesn't require an electrical supply. And the junction, there will be some sort of distance between the junction and the meter. Right? What are the disadvantages? Means it's not that much accurate. Right? The temperature adjustment is there, so definitely for this we require some proper shield in order to get your long life, the equipment to get your long life. And after that, the junction and the apparatus are very too much distances, right? So definitely there will create some error while getting the output from the instrument itself, right? So these are the brief discussion of a thermocouple. Now we'll move on to the concept of thermistor, right? Right? See, thermistor. So thermistor is nothing but thermal resistor. So we can call it as a thermal resistor. Right? So it is a resistive transducer. So it is nothing but passive transducer. Or nothing but resistive transducer. Right? So thermistor is nothing but a thermal resistor, right? It is nothing but a passive transducer, that is nothing but a resistive transducer. So it is used to measure the change in temperature by measuring the change in the resistance, right? A change in the temperature by measuring the change in resistance, right? So if you want to find out unknown temperature by measuring change in resistance, right? So that's why we can call it as a resistive transducer. So there are two types of thermistor, right? So there are how many types? There are two types of thermistor. The first one we can call it as a NTC thermistor, and the second one is PTC thermistor. Right? So NTC means so negative temperature coefficient. Right? PTC means positive temperature coefficient. Right? So how many types of thermistors? There are NTC and PTC. Now we'll see what is NTC and what is PTC. So NTC means so whatever the temperature which is inversely proportional to the resistance. So that means if temperature increases, your resistance is going to be reduced. Right? So NTC means a negative temperature coefficient. That means temperature increases, your resistance is going to be reduces. So what is a PTC? So PTC means positive temperature coefficient. So here if you increases your temperature, your resistance also increases. Right? So if a resistant temperature increases, your resistance also increases. So what are PTC thermistor? So PTC thermistors. So what are the PTC thermistor? If temperature increases, your resistance also increases. Right? So you know RTD, resistive temperature. You will get a question, sir. RTD is there for measuring the temperature by measuring the change in the resistance, but the RTD is a positive temperature coefficient. Right? So RTD is nothing but a thermistor also. It is also measure the temperature, but RTD is a positive temperature coefficient. So whatever the metals that you are using, the metal we can call it as a platinum. Right? So platinum, which is used at temperature increases, the resistance is increases. Right? How we can measure the resistance? By measuring the Wheatstone bridge. Right? How it will work means, right? So whatever the change in resistance that can be applied, so the bridge balance violate, and it will reach the deflection. It will reach the deflection voltage. So that much voltage is equal to the changing resistance. How the changing resistance? By applying the changing temperature itself. Right? So how it will work, you know, how we can find the changing resistance and all these things. So what is a PTC thermistor means? It's which works on the principle of positive temperature coefficient. So if a temperature increases, your resistance also increases. So first example is a RTD, and another example is a fuse. Right? So fuse. how the fuse will work? That means if you increases the voltage, so the definitely what happen? The current will increases. So when a current increases, your temperature is increases. When the temperature increases, definitely what about the resistance? Resistance also increases. If a resistance increases, your current is going to be limited. So how the fuse is going to be further increases? Definitely the fuse will broke and protect the system. Your temperature increases, your resistance also increases. So this is one more concept of a fuse in a PTC. Fuse is nothing but a thermistor. RTD is nothing but a thermistor, right? So but RTD is made up of metals. So where a temperature which is directly proportional to the resistance. If a temperature increases, resistance is going to be increases. Now basically all the thermistors are negative temperature coefficients. All thermistors are negative temperature coefficient. Very important question. So all the thermistors are negative temperature coefficient, right? So what is negative temperature coefficient means? Your temperature increases, your resistance is going to be reduces, right? So for 1 degree centigrade of temperature increases, so it will reach around 5% of resistance reductions, right? Simple 1 degree centigrade, which is a minute value of a temperature change, large change in a resistor, right? See one more time. So these are a negative temperature coefficients, right? If a temperature increases, your resistance is going to be reduces. So with the help of thermistors, for 1 degree centigrade, you are getting a 5% of resistance reduction. Small change in resistance, small change in temperature, minute change in a temperature, very large change in a resistance, right? So what about the sensitivity? Sensitivity is nothing but output by input now. So whatever the output which is very high, that means whatever the change in resistance which is very large change in resistance by input, right? Your output is very large change. That means what about the sensitivity? Sensitivity is very high, right? So that is the difference between RTD and thermistors, right? So RTD, the sensitivity is very less, right? So I hope it's clear, right? Sensitivity of a thermistor is very high. For a minute change in temperature also you can find with the help of these thermistors. I hope it's clear, right? So the temperature which can be measured up to minus 60 degrees centigrade to 15 degrees centigrade. So smallest changes for this only some thermistors that we can use, like body temperatures, right? So body temperatures, right? A thermistor is nothing but a thermometer, is nothing but a thermistor, right? So how it will work means if a body temperature increases, so whatever the mercury will shows the readings, right, in terms of voltages, right, in terms of measurements, right? Right? So whatever the temperature that you are going to measure up to minus 60 degrees centigrade to 15 degrees centigrade, very small minute change in a temperature also we can find with the help of these thermistor. So basically thermistors are made up of semiconductor materials. Very important concept. Right? So thermistors are made up of semiconductor materials. Why? Because these semiconductor materials, so where the temperature, negative temperature, which exhibits the negative temperature coefficients, right? Which exhibits if the temperature increases, your resistance is going to be reduces, right? Right. So the thermistors are made up of semiconductor materials. Where a temperature increases, your resistance is going to be reduces. So how the materials which are used for a thermistor means gallium, arsenic, manganese, right? Manganese. So these are the semiconductor materials. So we are going to be used in these type of thermistors, right? I hope it's clear. So thermistor is nothing but basically the thermistors are negative temperature coefficient. So the negative temperature coefficient means your temperature increases, so resistance value will be reduces. For a small change in temperature, various large change in a temperature resistance value. So for this, the sensitivity of the thermistors is very high when compared to the RTD also. Right? So after that, whatever the materials that we are going to use in a thermistors are a semiconductor materials. So why? Because these semiconductor materials will exhibit the property of negative temperature coefficients. So what are the materials? Means gallium, arsenic, manganese. So these are the metals that we are going to use in a thermistor because these are having a negative temperature coefficients, right? So basically the resistance variations are very less. So 0.5 to 0.75 ohms, right? So whatever the resistance changes for this thermistors are very less, right? So according to our operation, how much pressure, how much temperature, the thermistors are like bed type thermistors that we used. So you can call it as a bed type thermistors, right? Or disc type thermistors, right? You will use a disc type thermistor, right? Or after that a spherical type thermistor for a large pressure also, right? So how it will be like 2 leads is going to be there, right? Whatever the temperature that you applied, there will be a change in resistance. That change in resistance we can find out by the help of Wheatstone bridge and all these things. This we can call it as a bed type, disc type, right? Spherical type. So it depends on how much temperature. These are leads that unknown temperature that you are going to be applied here. Alright, so these are the different types of thermistors that we are using in our real life, right? And the symbol, how the symbol of thermistors, right? Right, thermistor is nothing but variable resistors, depends on the temperature. Right? So this is one type of showing the thermistors. Thermistor is nothing but variable resistance, right? But temperature increases, the resistance will be reduces, right? And one more symbol that you are getting is right. So this is one type of a symbol that so we can represent the thermistors, and another one like just draw like NTC, right? Simple like representation is like this, and PTC also like this. Simple representation of PTC. So these are the different types of different symbols to represent thermistors, right? So this is called variable temperature. So if you draw a variable line, means variable temperature like this. So we can directly show the NTC and PTC representation and all these things, right? Now we'll go for mathematical equation to represent thermistors, right? So mathematical representation. Right? So that is nothing but change in resistance R2, that is equal to R1 e power beta into 1 by T1 minus 1 by T2. Right? So R2 is nothing but resistance at T2 degree centigrade. R1 is nothing but resistance at T1 degree centigrade. So beta is nothing but constants. Right? So this is the change in resistance formula. So from this you will see, if you go for RTD, the relationship is a linear relationship between the temperature and the resistance. Right? So R2 is equal to R0 into 1 plus alpha T, alpha 1 T, all these things. So how the relationship for RTD? So if you take the resistance over here, if you take the temperature over here, so for a platinum RTD, the relationship is a linear relationship for RTD, like a platinum. So you are going to use a platinum material. Right? Now, if you use a thermistor, that is a negative temperature coefficient, how we can symbol the resistance and temperature which is exponentially decaying. Right? How it will be means? Right? So this is for thermistor. So whatever it may be, it's a gallium, arsenic, manganese, whatever it may be. Right? So this is a graphical representation, because you will see from the equation itself. So how it will be means, it's a exponentially decaying. Alright, so what is R2 means? Change in resistance at T2 degrees centigrade. R1 means resistance at T1 degrees centigrade, and beta is a constant value. From the graph itself, you will see the relationship between the temperature and the resistance. For positive temperature coefficients like RTD, it will be a linear relationship. The scale is a linear, but in the case of thermistors, the scale is a non-linear. You will see the exponentially decaying. Alright. Now, I just want to explain briefly the relationship between the temperature and a resistor in a single circuit, right? See, if the circuit is like right? So this is a simple circuit which is having a supply of 6 volt supply, and we are having a NTC, negative temperature coefficient resistor, that we can call it as a thermistor, right? And photodiode, right? So now we are applying, right? So when I place the circuit in hot and cold temperature, how the photo LED diode, how it will work, right? So right, when a 6 volt supply that we are giving across NTC thermistor with LED diode, is there it's a display, LED display diode, right, which is having a potential difference of 2 volts. Right, I am placing the circuit at first on a hot conditions, right? At hot conditions. So at hot condition, how my NTC thermistor will work? When a hot condition, your NTC thermistor means that the temperature is going to be increases. So NTC means if a temperature increases, your resistance is going to be reduces. Right? When a resistance reduces, your current is going to be increases. So when a current is going to be increases, your LED will be glow. Your LED, photo LED will be brightness. Alright, so now we are moving that this whole circuit in a cold temperature. In a cold, that means your temperature is going to be reduces. So what about resistance? Resistance is going to be increases. Your current is going to be reduces. And what about your LED? LED will show the dim. Right? So from here you will understand how the thermistor will work. Thermistor, there will be a clear relationship between the voltage and the resistance and the temperature, right? When move this circuit into the hot temperature, it will glow. When move into the cold temperature, it will like a dim. So these are the one how the temperature and the resistance will be varying. So with it you will clearly examine how the thermistor will work, right? Just you will show like whether NTC or PTC, just show the symbol like representation is enough. So this is about the whole concept of thermistor, and the graph represent the temperature and resistance characteristics of a thermistor. I hope it's clear. So what are the metals that you are going to use in a thermistor? Like in semiconductor metals. So what are the semiconductor metals? Gallium, arsenic, manganese, so whatever it may be, right? So why we are using a semiconductor materials? Because these are negative temperature coefficient. So what are the positive temperature coefficient? There is a RTD, fuse also a positive temperature coefficient, thermistors and all these things. So basically we prefer these type of thermistor in our life for a minute change in a temperature. So that's why the sensitivity of this thermistors are very high when compared to the RTD also. But a cost also very less when compared to the RTD. See, the cost is RTD is very cost. Then thermocouple. Then thermistor. Right? So for a cost based issue also, your thermistors are very less cost when compared to all the temperature measurement devices. I hope it's clear how it will work, and different shapes, and what are the symbolic representation and what the mathematical representation, graphical representation of a thermistor, and I explain with simple circuit how it will work when a temperature increases, how your LED brightness or dim, like that you will clearly understand how my NTC thermistor will work and all these things, right? Now we'll see the advantages and disadvantages of a thermistors, right? Right? The first one is sensitivity is very high. Right? So the cost is very less. Right? For a minute change in temperature. Next, it's a small in size. Right? Small in size, and the response is very fast response for narrow temperature variations. Right? So what are the advantages? The sensitivity of the thermistors are very high, and these are less cost. Right? So minute change in a temperature you can easily find out, and the small size you will find these type of thermistors are very small in size, and you will get the fast response. So with the help of these thermistors, right? Next, second one, disadvantages. Right? Not suitable for wide range of temperature. Large temperatures it won't work. And second one is, if a temperature increases, so what about the resistance is reduces? So if the resistance reduces, the current will going to be increases. So this excitation current will damage the system if not proper shielding won't provide it, right? Excitation current damage, right? If not provide proper shielding. So if you are providing proper shielding means protect from the system from a stray electrical, stray magnetic field and all these things, right? And the third one is, whatever the scale that you are getting, which is a non-linear scale, that means temperature, resistance scale, you are getting a non-linear scale. Right? So these are the disadvantages while using these thermistors, right? So it is not suitable for a wide range of temperature variations. Right? It will be used for minus 60 degrees to 15 degrees centigrade. Right? So it is very very small change in value. So if a small change means enormous change in voltage, change in resistance that you will get. Right, if temperature increases, so resistance is going to be reduced, then maybe excitation current is going to be increases. If you are not protect the system from a proper shielding, this excitation current will damage the thermistors, right? And whatever the scale, you are getting a temperature and resistance scale, which is a non-linear scale. Right, so these are the disadvantages of a thermistor. So this is the whole concept regarding the thermistor. Right, all these things. Just what we discussed about what is a thermistor. Thermistor is nothing but the temperature, thermal resistance, right? So you can measure the temperature by measuring the change in resistance. Maybe you'll get a question like RTD is there, but RTD is not that much sensitive. It is used for a positive temperature coefficient, but NTC, but whatever the thermistor we are using a NTC, negative temperature coefficient, right? So these are made with semiconductor materials. So if a small change in temperature, enormous change in resistance, so that means the sensitivity of this one is very high. Alright, so this is called a resistive transducer. Materials that we are using is nothing but gallium, arsenic, manganese, like that semiconductor materials. Alright, so after that there will be lots of shapes, depends on a pressure on the temperature. There will be a bed type, disc type, and spiral type also. We are using these type of thermistors and different symbols that we discussed. After that, what is the relationship between the mathematical relationship between the resistance and temperature? The resistance R2 is equal to R1 into e power beta into 1 by T1 minus 1 by T2. So with this, we'll say that the resistance and temperature relationship is a non-linear relationship. Right, so for we will discuss about both RTD and thermistor, how it will be related, so by graphical representation itself. And we discussed about small circuit, how the temperature variations, how the resistance should be vary, and the LED glow and all these things that we discussed. So after that, we discussed about some advantages and disadvantages of thermistor. So these things are more than enough for your end exams, for your competitive exams also. So this is about the thermistor. In the next session, we will discuss about what is photoelectric transducer and the photodiode. Both are very important concepts. Synchros, I need not to explain the synchros because you know about the synchro concept very well. But I'll give brief thing about the synchros. I think we did an experiment also regarding how the synchros will work and all this, but that's why I don't want to explain another time because it's a waste of time about this. Thank you for now. In the next class, we discussed about piezoelectric transducer and photodiode. Thank you for now.